Hello everybody, how are you doing? Welcome back to the final revision session for this week. A couple of things before we start. I will put the next batch of live stream thumbnails or schedules up in the next couple of days, but I will be carrying on until half term, so there'll still be another 2 weeks of lessons or live streams. What else do I need to tell you? Yeah, we're just going to carry on with the exam paper that we were doing. So let's do that. I'll just checking to see that it's working. Hello, everybody. Yeah, it is good. I can hear myself. Excellent. Right, so let's have a look at what we're doing. Yesterday, we were looking at this paper here, and we finished on the errors in code question. And here is the code. There are 4 errors in this code, and you need to find them and correct them. So you might have looked at it before, you might not have done. I'm just going to give you a few minutes to have a look at this and find some errors for me. If anyone's found any errors, do put them in the chat, or even if they think that they're errors, doesn't have to be, might not think they're actual ones. If anyone's found any errors, do put them in the chat. No one is volunteering anything at all. I'll just give you another 2 minutes to try and find something. Oh, someone said, is total supposed to be a real? Yeah. That's okay. Yeah, could be a real. There is an issue with one of the declarations though, so I'll give you a clue. Should I tell you the line numbers or give you a clue? So there is one of these declarations is the wrong data type. Shall I use red? Teacher red. So one of these is the incorrect type. There's an error on line number 7. There's an error on line number 9. And there is an error on line number 10. So see if you can spot the errors there. Yeah, good. Someone spotted that the first line here, line number 1, loop is a string, but it should be, it's not a string because if you're using it to loop round and you're comparing it, or in this case here, then it should be an integer. So that one is our first error. It should be an integer. Good. Well done, everybody. Or who specific was. Vivian Loves Music, 9916. Well done. Okay, what's the error on line 7? Okay, no bad language, please. But yeah, this is computer science, IGCSE computer science, and it's the programming paper. Can I explain what line 6 is for? So yeah, so line 6 is basically, it says it's allowing a random number between 1 and 20. So it's basically working out or getting a random number between 1 and 20. It's not a very good way of doing it because it's got like a +1. And it does speak to me to say that they actually have put this in just to confuse people. Because it's got random times 19 this one's rounding it actually, so that's rounding it, and then we're randomizing 19 numbers. So yeah. Where are you from? I sound British. I am British. Yes. Correctly identified my nationality from my accent. Okay, so on line 7, the problem with this is if you look at and sort of look at the block of code that this is, it's got next loop at the bottom, and you don't end an if statement with next, you end a for loop with next. So actually this one here should be a for instead of an if. So that's our next error. And then line number 9, this is the wrong variable. So we're not inputting the loop, we're using the loop in the loop. So that's going to be total instead. Value. We're inputting a value instead. And then on the final line, total equals total times value. Well, we're summing something. If we're totaling something, we're summing it. So it's not times, it's plus. So that's the final error. So I think this is kind of very typical of the sorts of errors that they'll put in. Always do check for the declarations to see are those the correct data types, including if there's any arrays. And then for this one here, if there is, the begin and the end of a block, it should be for next. It should be 1 while, end while, and then if, end if. Just check for those because classic. And also case, actually. Case should be end case. Check that it's the correct variable that's being used, and check the what do you call it? The plus, the minus, the times, etc. Just check that that's correct. Okay, let's look at the next question then. And the next question is, we'll look at more next time. The next question is on here. Write the pseudocode statement that would output the average calculated in line 13 of the algorithm rounded to 1 decimal place. So see if I can get that both on the screen. So line 13, which is the last line of code, write the pseudocode statement that would output the average calculated in line 13 of the algorithm to 1 decimal place. How do you do that? Yeah, so someone's pointed out that there is a problem with the division. If it's a 0, then it would break. But because this is GCSE level, so sort of 16-year-olds school age, you don't have to worry about that. I just assume that it's not 0. But that is a good point, yeah. We don't want any division by 0. That will cause an error. Okay, so for this one, if we're getting the average output here, all we're doing is we're using total divided by limit, and we're putting the round function around it. So, and we're using it to 1 decimal place. I'll just show you the answer. It's easier than me typing it. And just a nice use of it. They do quite like you to know how to do round. So there we go. We use the word round. We put our calculation in it, or it could be a variable, and then it's comma to 1 decimal place. So it's just round total divided by limit, comma 1. And you get 1 mark for using round, and then 1 mark for the correct parameters. Yeah, good, excellent. Okay, next one then is explain how you should alter the original corrected algorithm to make sure that all the numbers entered are between 1 and 500 inclusive. If any numbers fall outside these limits, a replacement value is requested and entered. You do not need to rewrite the algorithm. Now, when they say explain this, you don't have to write pseudocode. You can just explain to say what you're going to do. What I'll do is I'll put the original or the corrected algorithm up for you. Here's the corrected algorithm. And then I'll just rearrange my screen a bit. It's always a bit of a pain trying to rearrange my screen, but we'll get it going. There we go. That's it there. Oh, a bit smaller. There's the corrected algorithm. And we're going to explain for 4 marks how you should alter the original corrected algorithm to make sure that all the numbers entered are between 1 and 500. If any numbers fall outside these limits, a replacement value is entered. So that's basically where we are putting it in is round about here, line 9. So there's a little clue for you. There's lots of silence from me in these questions because obviously you need to write a bit more. Yeah, you're doing part C. Yeah, that's correct. Yeah. But it's explained. You don't have to write the pseudocode. Yeah, so someone said if we use an if condition, that can check if the value is less than or greater than 500. If it's more, ask for a different value. Yes, and that's almost right, but not quite. So if you think, though, about, so you are kind of correct, you do need to check it, but we don't know how many times the user is going to enter an incorrect value. And if we use an if statement, we can only check it once, but they might enter it like 500 times, or they might enter it twice. We don't know. So if we know we're going to have to do it more than once, we need a loop. And which loop is a looping if statement? So you're really close. A while loop, yeah, perfect, yeah. Now you can, yeah, so someone else has suggested a repeat until. You can use a repeat until as well. I mean, my preference is always a while loop, and if any of my live students or my students know me, know that I do not like repeat until, but it is a valid loop. I was always taught never to use them, but yeah, you can use it. And if I show you the answer in a moment, you'll see that part of the mark scheme has got a repeat until. So yeah, good. So someone said to ensure that all numbers selected are between 1 and 500, a validation check should be added after the input. After a value is entered, the algorithm should check the value. Yes, try and be a bit more specific with a while loop, which you've done in the next bit. If it's outside the range, the user should be asked to re-enter the value. This can be done using a while loop. So perfectly, yeah, excellent, good. Value until the valid number is entered only when the value is within the range should it add to the total. Yeah, good. So that is quite long, but ultimately, yeah, all we do, in actual fact, I'll go to my my pad here. Yeah, we would basically, we have input value. Oh, I'll use a darker colour, sorry. Then you might be able to see it. There we go. So all we do is we have our input value, and we would then have a while loop to say while value is less than, what was it, 1 and 500? less than 1 or value is greater than 500, we could do output value should be, hang on, one second, my cat came in and I can hear the rest of the house. Value should be 1 to 500, and then we input the value again. So it is a classic range check, and then we just have end while, and that is basically the range check. So what we would write in the exam, we don't do, because it says explain it, we would say after line 9, so something along these lines, after line 9, add a while loop that checks if value is between 1 and 500 inclusive. If it is, then the while loop will be skipped. If not, then an output statement should alert the user, just write this up a bit here, should alert the user to enter a value between, or to enter the correct value. There should then be another input value command. So that's what they're after, is this rather than the pseudocode. And even if you're kind of not sure, you're in the exam and you're like, oh, I'm not quite sure, just give it a go, and you kind of think you know roughly what you're going to do, then, you know, that's fine. Would a function work too? Yeah, I mean, a function would work, absolutely. Yes, you could put a function, but I would say you're probably overcomplicating it for the GCSE. They're not really, although we do have functions and procedures in the GCSE, it's not something that they'll be after testing you in this particular one anyway. Now, I said a moment ago that you could have a repeat until. So you could have here, so instead of that, in fact, I'll just write it, it's easier. Remember that repeat until is like an upside down while loop. So we would have line number 9, there we go, input value, but we would have repeat input value, and then we would have whatever we're doing after that, total equals total plus value. And then until that's not quite the right way around. Hang on a minute. This is why I don't like repeat until. Then they're illogical. I don't like them. We input the value until value is greater than 1 and less than 500. And then we would have the other code after that. And then again, we would explain that. We'd say line 8, between line 8 and line 9, you would put repeat. Then we input the value until the value is greater than 1 and less than 500. Okay, let's move on because we've got more pseudocode. Woohoo! More pseudocode. That's the answer. So let's look at the questions. Where are the questions gone? Hiding behind here. There we go. So the next question is writing a pseudocode statement to perform this task. So actually, a lot of you who are my students will know this was your in your end of year assessment. Again, I used a lot of this paper for your end of year assessment. So write a pseudocode statement to perform this task. Accept the input of a whole number from 1 to 4 inclusive. Use a case statement to output the number 1 to 4 inclusive that was entered. Output the word error if a 1 to 4 inclusive error was not entered. So I'll just give you 1 more minute and then I'm going to go through it. Okay, so for this question, we're just writing a case statement. So we've got input. It says input a whole number. So I'm just going to put input number. And then we're going to use a case statement. So we just do case of number. And then it says from 1 to 4. So it's going to be 1. And what are we doing? We're outputting that number that was entered. Absolutely pointless, but there we go. Output 1, 2, we're going to output 2, 3, output 3, and 4, output 4. And then output the word error if a 1 to 4 inclusive number was not entered. So basically that's going to be otherwise, which is just like an else. So it's otherwise output error. And don't forget to end your case. Because if we look at the mark scheme, let's look at the mark scheme, if we can find it. There it is. For all the mark scheme, the marks are 1 mark for the correct input statement. So always be careful with this, because even if you get to the exam and you're in the exam and you're like, oh, I can't remember how to do case statements, you can still get 1 mark for the input statement. So always look at the whole question and think, is there, this is really hard for me, I really can't remember it, but is there anything that you can remember? Like this one, which is just an input. Then you get another mark for elements of selection statement. So basically the case of end case. So the case of, and then the end case is another mark. At least 1 correct branch in the case statement. So at least 1 of those. And then all branches, then you get another mark. And then the otherwise, you get the final mark for the 5th mark. If the number 1, 2, 3, 4 of the algorithm outputs the number entered, if any other number entered, yeah, that's right. But so for this question, they did want you to write the actual pseudocode. So obviously it's quite hard in the chat. I realise that. The algorithm should first accept the whole number. A case statement should then be used to check the value. Yeah, that's correct. Yeah. Oh, and you have done it correctly. Yeah. Declare num. So in this case, you don't have to, well, we have got, so they're a bit inconsistent. So you've declared the variable there. The main problem we have with this exam board is they are quite inconsistent regarding declaring variables. So actually what I would say is, if it doesn't say whether or not to declare a variable, probably declare it. But someone's asked, is the colon between the otherwise and output needed? No, that you don't need a colon there. No, you don't. If you see here, it's just otherwise. Yeah. Okay, good. Okay, next question. Now the next question is a trace table question. So we have got a lovely flowchart here. And can anyone tell me, just if you have a quick look at this flowchart, what this flowchart is doing, especially based on this section here, where I've kind of highlighted it. Not the flag bit, but this bit here. So let's be nice in the chat. Please, everybody, let's be nice. What is this doing here? What is this algorithm? At first glance, what is it telling you that this is actually doing, this algorithm? Especially the blue bit that I've highlighted on the right. It's adding 1, it goes through the loop. It is adding 1. What I'm trying to get at is the overall algorithm is actually a bubble sort. And this is a later question. So it says outline the process here. I'm telling you it's bubble sort because this is a little bit complicated. So yeah. So what I'm going to do is I'm going to attempt to get both of these on the screen for you so that you can try to do the trace table. So you might need a pen and paper to draw this. Let me just close that down. And there is the screenshot. There's quite a lot of columns in this one because it is an array that you are sorting. So you've got an array here with numbers, and we're going to basically fill out this, and it's a bubble sort. So we are going to need most of these rows. So try drawing, just getting a piece of paper and writing limit count, everything across the top here. Remember that each one of these columns is a variable, or as we can see in numbers, it's an element of an array. And we're going to only change each one of these if there is a arrow. So we're setting a value, assigning a value, or we're inputting a value. So, and this part here where we've got swap, etc., this is where we swap the values. So I'm going to go quiet again, see how you get on with this. And I might start you, if you get really stuck, I'll start you off and do a couple of rows, okay? Okay, so I'm going to go through this because we're going to run out of time. So it is so tricky to get this on the screen though, so that you can actually see it and we can see the flow chart. So I'm going to give it a go though. We don't need, actually, we don't need swap and result yet. So anyway, we start at the start. We input the first limit, which is 7. So we put 7 here and we've got count equals 1. So we set count equal to 1. We input numbers count. So basically we've got 47. So that goes in the first one. Then we've got, we increase count by 1. So increase count by 1. So that's 2. Then in that one, we put in 50. Then we increase count. Is count greater than the limit? Greater than 7? No, it isn't. So we loop around again. We input the next count, which is, we increase count and then we put it here, which is in 52. In the third one, we loop around again because we've increased count by 1. We input the next one, which is, so we've done that one, it's 60. And then increase count by 1. So that's that one there. It's not greater than the limit. We loop around again, input the next one, which is 80. Increase by 1. That's 63. Increase it by 1. It's 7. And then we're adding the last one there, which is 70. Okay, so we've got that all set up. We set the flag to true. So set the flag to true. And then is flag equal to true? Yes, it is. It's not displaying everything. Is the flag set to true? Yes, it is. So hang on, just one sec. Okay, so sorry about that. Next is we're going to we're here, we've set flag equals and we set our count equal to 1. Is count greater than the limit minus 1? So is 1 greater than 7 minus 1, which is 6? No, it isn't. This, by the way, this is a really complicated one. Okay. So don't worry if you're struggling. No, it isn't. So we follow up. No, that's the wrong one. So it's there. Sorry, we're now going here. And is numbers count greater than numbers count plus 1? So this is basically the bubble sort where we're comparing is 47 greater than 50? And the answer to that is no, it isn't. So we follow the no and we just count equals count plus 1. So that's 2. We're down here, count equals count plus 1. Is count greater than, so is 2 greater than 6? No, it isn't. So we go up here and we compare the next two. So it's 50 and 52 that we're comparing. Is 50 greater than 52? No, it isn't. So we just go down again and we increase count by 1. And in fact, we're going to keep going. So is count greater than limit? So is 3 greater than 6? No, it isn't. So we go up here and we compare the next two. So count is 3. We're comparing these two here. And we've got 52 is not greater than 60. So we increase by 1, which is 4. Is 4 greater than 6? No, it isn't. So we go up here again. And we're going to compare 80 and 63. So this is where finally we've got 2 that can be swapped. So what do we do here? I think I actually needed to increase that by 1. So yes, it is. So we're going to swap. Swap becomes equals to numbers count. So that's 80. So because we're up to 5. So swap becomes equal to 80. Yeah, good. Yeah, well done. And then we've got the next line, which is here, numbers count. So that's numbers 5 equals here to numbers count plus 1. So 80 becomes equal to 63. And then next one here, count plus 1 becomes equal to 80. Or the swap. And then the flag equals true. Count equals count plus 1. So we swap the number. We go up to number 6. Is count greater? So is 6 greater than 6? No, it's not. It's the same as. So we still do the no. And then we've got is 80. So this one here is now asking, is 80 greater than, this one here is 70. Is that greater? No, it isn't. Sorry, yes, it is. So we're going to swap again. So what happens when we swap? Basically, we put our swap value in. So it's going to be 80 again. So swap equals numbers count. So count is 6. So it's this one here, 80. So it becomes equal to 80. And then this one here, we swap it over. That becomes equal to 70. Then the next line, we're setting it to swap, which is 80. So we've swapped them again. And actually what you can do is you can write in all of these as well. That might help. You don't have to keep them blank. You can write them in, by the way. So that's 63, 70, 80. We set that to be true. Count equals count plus 1. So that is 7. And it is now bigger than 7. So we go up here. Is the flag true? Yes, it is. We set the flag to false. And then the count to 1. So we're going back round again. The crux of this last bit is we're doing the same thing as we did before. Here, is count greater than 6? No, it isn't. But this time we're going to compare each one of these, each pair as a bubble sort, and they're basically going to be the same. 47, 50, 52, etc. They're all the same, so we don't have to do anything. But we do need to increase our count each time where we're comparing them. And then finally, we will finish. And we just need to, once we're here, the result is the limit div 2. So limit is currently 7. Sorry, yeah, 7. Div 2, so divided by 2, that is 4. And we have, so that would be 4 plus 1. No, sorry, it's 3 plus 1. So that would be 4. Can't see the result. And then the output is here, numbers result, which is 60. And what that one's doing is it's finding the mid value. So this bit here is finding the middle value of our array. So here we've got 63. and we've also got 70 and 80 there. So I know we've overrun a bit, but it only by 5 minutes. And that's the mid one. And then everything else is, yeah, that's the mid one. So this one is hard. What I would suggest is, with the trace tables, is to pick out the hard ones, go through the papers. I mean, we'll be doing a few, obviously, in these sessions, but if you pick out the hard one, if you get an easy one, then it's going to be easy for you when you sit the exam, because you've done all the hard ones. Okay, we've run over, so I hope that was okay, everybody. Yeah, these can get quite hard, so I hope that helped. See you next week. I will add the thumbnails up for you soon. Okay, take care, everybody.